A ball is dropped from a state of rest and falls, and there's no air, so we can ignore the effects of air resistance. The only thing pulling on it is gravity. Which is true about its motion? Let's think about this for a second. Is acceleration occurring? Sure it is. So we know that's definitely a possibility. Is its velocity constant? Probably not. It's going to change velocity as it falls. As it falls, could its velocity decrease? No, it'd have to be thrown up. If it's dropped from rest, it would do that. So is acceleration decreasing or is it constant? Think about the previous conversations we've had. We said that gravity is always pulling down on something with a rate of g. No matter where you put this object in space, when it's flying up in the air, boo, going up, or boo, falling down, gravity is always pulling on it at a constant rate. Whoa, well there's the answer. What is the acceleration due to gravity? It's constant. Indeed, the answer is A. But let's hide that answer and revisit why this is true. If I drew a velocity time graph for this object, this is velocity as time progresses. Its starting speed would be there because I'm dropping it from rest, so that would be 0 meters per second. Remember, this is positive. These are positive values. These are negative. And then as time goes on, its velocity is going to increase a bit. And then more time goes by, its velocity increases, at least in the negative direction, some more. Its time goes on even more, its velocity goes up. If I jump up and draw a line that gives us the velocity as a function of time, we end up with a straight line. And the slope of this line will determine the value for the acceleration. So if we come up here and look at this small region, how does the slope of the line there compare to the slope of the line there, compare to the slope of the line there? Because remember, acceleration is delta v per delta t. So we experience a delta v in all of these cases. A delta v occurs there, a delta v occurs there, a delta v occurs there, and these delta v's are pretty similar. They're delta v's per delta t's, are relatively similar. The rise to run. There's a little bit of variation in the way I drew it, but the slope of the line, the change in y per change in x, which is the slope of the line, which is the acceleration, is or are constant values. So the acceleration due to gravity is indeed a constant. Let's do a little. The acceleration due to gravity is a constant in every time, in every way.